Now we did the first part of the chapter, that is the rate of reaction. Now let's talk about the factors which are affecting the rate of reactions. As I said, there are the various factors in the beginning only. The factors are the concentration of the reactant, temperature, pressure, the catalyst or the surface area of the reactant or the nature of reactant. So first I'm starting with the first factor, that is the concentration of reactant. We have the next part that is called rate law. Rate law, which tells us about the effect of concentration of the reactant on the rate of reaction. Just keep in mind that rate of reaction is always, it is directly proportional to the concentration of reactant. The concentration of reactant in the beginning means it is directly proportional to the concentration of reactant. Directly proportional to the concentration of reactant means as the reactant goes on increasing, the rate of reaction also increases. If the concentration of reactant decreases, the rate of reaction also decreases. During a reaction, I can say with the time the reactant amount goes on decreasing. So simultaneously the reaction speed also goes on decreasing. It means if I'm asking like when the reaction is the fastest one, at what time the speed of the reaction is very high, then simply answer is when the reactant concentration is very high. It means it is in the beginning of the reaction, because in the beginning of the reaction the reactant concentration is very large, but with the time the reactant concentration goes on decreasing, and if the reactant concentration decreases, that is the rate of reaction decreases. So here we have the rate law. In chemical equilibrium, we had studied a law that is called as law of mass action. Okay, so in chemical equilibrium, we are having a law called as a law of mass action. What was that law? The law is also tells us about the rate of reaction and the concentration of reactant. According to that law, the rate is directly proportional to, here I am writing the law, the rate is directly proportional to the product of the molar concentration of reactant. Instead of word molar concentration, we can also use active mass. So rate is directly proportional to the product of molar concentration of reactant. We are having two reactant A and B. So directly proportional to the concentration of first reactant A and then second reactant B, and there is a product. With each concentration term raised to a power equal to stoichiometric coefficient, means in this each concentration term is having some power, and that power is coefficient. So in this reaction, capital A and capital B are reactants, capital C, capital D are product. These are components, while A, B, C, D are the coefficients. So A raised to A and B raised to B. This was the law of mass action, which tells us about the dependency of the rate of reaction on the concentration of reactant. But the problem was that for the certain reaction, we observe that the powers are coefficient, but experimentally when we observe for some reaction, then we come to know that in all the cases the power is not the coefficient. Means experimentally when it is observed, then we come to know that in some cases the powers are coefficients. In some cases it is coefficient, but in some cases the powers were other than coefficients. Matlab it is not equal to coefficient. So the law was modified, and now instead of saying that the power is always coefficient, we say that here the power is going to be some suitable number. It may be anything. That number cannot be predicted but just by looking to the reaction, but it is going to be some number. So if I am writing the rate of reaction here, the rate is directly proportional to, I am just writing the modified form of the law of mass action. It is directly proportional to the product of the molar concentration of reactant. Now instead of saying that the power is going to be a coefficient, as I said, in some cases when we perform experiment, then we come to know that it may be the power, in all the cases the power is not coefficient. So here I am just writing the powers as a x and y, where x and y is a what? It may be equal to coefficient or may not also. The x and y, what will be the value of x and y? To know that, you have to perform experiment. Without performing experiment, no one can predict the values of x and y. So if you want to know the x and y, perform experiment, collect data from it, and from that data we determine the values of x and y. So here in the next step I can say rate is equal to K into molar concentration of A raised to X and B raised to Y. And this equation is called as rate law. Means here, as the name says, the rate law is not any law or anything. It's just a name of this mathematical equation. That is rate, which tells us about the relationship between the rate of reaction and the concentration of reactant. Or I can say which tells us about the dependency of rate of reaction on the concentration of reactant. As I said, what is X and Y here? Then X and Y are experimentally determined equation. Experimentally determined power, which may or may not be equal to coefficient. And this equation 1, as I said, what is equation 1? Then equation 1 is called as rate law. So whenever I'm using a word rate law, it doesn't mean any law. It means I just wanted to know the relationship between the rate of reaction and the concentration of reactant. Now what is K here? We have one more term, that is K. K is, since it is a proportionality constant and it's a constant during calculating the rate of reaction, so this is called as rate constant. Or sometimes it is also known as specific reaction rate. So this is about the K. Now let's talk about the rate constant. Again, an important thing for a chemical kinetic. Rate constant. I'm starting with the same equation, that is rate is equal to K into molar concentration of A raised to X and B raised to Y. I wanted to know the K, what is K actually, how it is determined. Then simply I will say take all the reactants concentration as a 1 molar, means during the reaction whatever the number of reactant we are having, consider all of them as a 1 molar. So if A and B is 1 molar, 1 raised to anything is 1, 1 raised to anything is 1. So ultimately you will get rate is equal to K. Now this gives the definition for K. What is K or what is rate constant? It's nothing but the rate of reaction when all the coefficients are equal to 1 molar. Means suppose if I have this particular reaction and I wanted to know the rate constant for this reaction. So for the rate constant I can say consider this A and B. Consider the concentration, that is the amount of both A and B as a 1 molar. And initially whatever the rate of reaction you will get, that rate of reaction will be the value of K. And for a given reaction, the value of K is always constant. For a given reaction, the value of K is always constant. It does not changes. K, it only depends on one factor, that is called as temperature. Only the temperature is a factor which affect the rate of rate constant value, or there is no other factor. Okay, after this, the next is unit of K. That is unit of rate constant. Now let's try to derive this unit. K is equal to formula we have rate upon, from this, molar concentration of A raised to X and B raised to Y. The unit for the rate we did, it's M molar per time. Let I'm considering it's per time upon concentration of A. Molar concentration, so M raised to X, and this is also concentration, so M raised to Y, which can be written as molar per time upon M raised to X plus Y, or it can also be written as molar per time upon M raised to X plus Y. Instead of X plus Y, I am writing N. What is N? It is equal to X plus Y. And here the N is known as order of reaction. Now what is order of reaction? We will learn about this order of reaction also in the same chapter. So N is the order of reaction. So ultimately from here I can say the unit of K will be, it is m raised to 1 and m raised to n. So it is going to m raised to 1 minus n per time. So this is the unit of rate constant. Unit of rate constant totally depends upon the order of reaction. Order of reaction decide that what will be the unit of rate constant. If n value is 1, it is going to be m raised to 1 per time. If n is equal to 2, it is going to be m raised to minus 1 per time. If it is 3, then so on. Or instead of m, that is molar concentration, we can also write here mole per liter raised to 1 minus n per time. So we have these two unit, or I can say if I am opening a bracket, then it is going to be mole raised to 1 minus n, liter raised to minus 1, so minus 1 will change the sign, so it will become n minus 1 per time. So we are having these two unit for rate constant. Either use this or use this. Instead of liter, I can use dm cube also. So we are having these two unit for rate constant, this or this. After rate law, the next is the order of reaction. Order of reaction, just we did the same thing in the while writing the rate constant unit. It is represented by small letter n. Order of reaction. Suppose, what is order of reaction before this? Let's talk about something. Suppose we have this reaction. Consider a reaction. A moles of A plus B moles of B gives C moles of C plus D moles of D. Right, rate law for this reaction, the rate law was rate is equal to K into molar concentration of A raised to X and B raised to Y. Where X and Y are the powers, I said these powers cannot be predicted. If I wanted to know the values of X and Y, then simply I have to perform experiment, and from the experiment we get the values of X and Y. Okay, now let's talk about certain reaction and their rate law. And let's see whether we can predict the values of X and Y or not. So let's talk about some reaction. The first one, suppose I have a reaction H2 plus I2 gives 2 HI. So we have certain reactions, and let's write the rate law for this reaction. The first one is H2 plus I2 gives 2HI. I wanted to write this rate law. So rate is equal to, rate law means experimental equation which tells us about the relationship between the rate of reaction and concentration of reactant. While writing a rate law, what we can write? We can write rate is equal to, we all know that in rate law there will be a rate constant, that is K. We have two reactants, that is H2 and I2. So we can write only this much, that is rate is equal to K into H2 into I2. What about the powers? If I wanted to know the powers, then simply, as I said, you have to perform experiment. So let's perform experiments. So from the experiment we got the data, and from data we come to know that value of, or the power of H2 is 1 as well as the power of I2 is also 1. So in this case I can say both are having a power as a 1 1, and in this case I can say okay, the coefficients are also 1. Means in this case, for this particular reaction, I can say the power and coefficient is 1. Both have, means coefficient power is same in this case. Here for the second reaction, 2 moles of NO plus O2 is giving 2 moles of NO2. If I wanted to write rate law for this reaction, then rate is equal to, it is K into molar concentration of NO into molar concentration of O2. Again I perform, suppose I can write only this much. Now the next is a power. If I, again for power I perform experiment, and from the experiment we got a data, and from data I come to know that x is equal to 2, that is power of this is 2, and y is equal to 1, means its power is 1. Again I can say for this particular reaction also the power and coefficient is same. Now let's talk about this particular reaction. Here it is rate is equal to K into molar concentration of NO2 into molar concentration of CO. Again for writing rate law I can write this much. So again the question is power. In this case when I determine the power, I come to know that power of NO2 is 2 and the power of CO is 0. It means here I can write K into NO2 whole square. Anything raised to 0 is 1. So rate is equal to K into molar concentration of NO2 raised to 2. Now in this case simply I can say that power and coefficient does not matches. How we got 2 and 0? This simply I will say from the experiment. From the experiment we got the data, and from that data we deduce the values of x and y. There are the certain reason also for getting this powers as a 2 and 0. We will do that in the mechanism when we will learn about the mechanism of the reaction. So rate is equal to K into NO2 whole square currently for this much time. Then for this, rate is equal to rate law. Rate is equal to K into molar concentration of CS3CHO. Again the power. Here when I perform an experiment, I come to know that power is 3 by 2. It means the power may be fractional also. Again the power and coefficient does not matches. When I'm talking about this reaction, rate is equal to K into, there is a one reactant, that is ammonia. And then coefficient it is 2, but when I calculated the power, I come to know that power is 0. That means I can say rate is equal to only K. Rate is equal to only K, what it means? It means that rate does not depends upon the concentration of reactant. There is only one reactant, but the rate of reaction does not depend on it. So rate remains constant. Now let's talk about this reaction, the rate law for this. We have rate is equal to K into molar concentration of H2O2. Again the coefficient is 2, but when I calculated a power, I come to know that power is 1. So by just observing these reaction, I can say that in this case I cannot predict the values of x and y, because it may be coefficient or it may not also, and if it is not coefficient, then what will be the value again can't be predicted. It is determined only by performing experiment. Okay, now let's talk about this example. This example tells us that rate is direct. If I'm removing K, then I can say rate is directly proportional to NO whole square as well as it is directly proportional to O2. Means rate of reaction depends on NO as well as it depends on oxygen. Now the question in my mind is that rate of reaction depends on which concentration more. Means whether the rate of reaction is more dependent on NO or more dependent on O2. So let's determine. For determining that rate depend on which reactant the rate of reaction depend more, simply I will say just change the concentration of both NO as well as O2. Change them by the same amount and just see that rate of reaction, in which case the rate of reaction is more affected. So first I am changing the concentration of NO. So as I said, change should be same. So I'm doubling the concentration of NO. On doubling concentration of NO. So if I'm doubling the concentration of NO, it will be rate is equal to K into, suppose if it was 5, then now it will become 10, means whatever the initial amount multiplied by 2, so it will become 2 into NO whole square into O2. 2 will come outside, and since you double the rate of the concentration of reactant, ultimately the rate of reaction will change. So I'm writing it's a rate dash. It is equal to 2 will come outside, it will become 4 into K, 2 square, so 4, NO whole square into O2. So I can say that rate dash is equal to 4 times of this K into NO whole square into O2 is nothing but the initial rate. So I can write rate dash is equal to 4 times of rate. Means if I am doubling the concentration of NO, then the rate of reaction changes by a factor of 4, means it increases by 4 times. Now let's see what happens if I'm changing only the concentration of O2. So on doubling the concentration of O2, again the rate of reaction will change. I'm representing it by a double dash. K into NO is same, only the change is O2. O2 is doubled, that is 2 O2. Again 2 will come outside, the power is 1, so 2 will come outside as a 2 only. K into NO whole square into O2. So rate double dash is equal to, it's a twice, and this KNO and O2 is nothing but the initial rate, means I can say rate double dash is twice of rate. So from this I can say that if I'm doubling the concentration of NO, the rate of reaction increases by 4 times. If I'm doubling the concentration of O2, the rate of reaction increases by 2 times. So just by looking to this example, I can say rate depends more on which reactant, then simply the answer is NO. Because when the same change is done, the rate of reaction changes more for NO. So on the NO, the rate of reaction is more dependent. Why it is dependent more on NO? I can say the power is 2. So whatever the number will be there, when it will come outside, it will become square. So ultimately I can say the rate of reaction, mainly rate of reaction, on which reactant it depends more, it simply decided by the powers. The reactant having a higher power more affect the rate of reaction. Okay, so if I'm talking about this, rate is equal to K into H2 into I2. Both are having power as a 1, 1. If I'm doubling the concentration of H2, how much the rate of reaction will change? I will say doubling. So 2 will be there, it will come outside, the rate of reaction will be double. I2, if I'm doubling the concentration of iodine here, how much reaction will change? Again 2 twice. In this case, I can say if I'm doubling the concentration of NO2, doubling the concentration of NO2 means there will be 2, it will come outside as a 4, means the rate of reaction changes by 4 times. If I am doubling the concentration of carbon monoxide, it will be 2 raised to 0, again it is going to be 1. Means on doubling the concentration of carbon monoxide, the rate of reaction does not changes, that is rate of reaction does not depends upon the carbon monoxide, and that's why the power is 0. Power is 0, it means rate does not depend on it. Okay, if I'm doubling the concentration of both NO and O2, what will happen? If I'm doubling both, it will be 2 and this will also 2. From this 2, the 4 will come outside. From this 2, only 2 will come outside. That is, it is going to be 8 times. The rate of reaction will be increases by 8 times. If I'm doubling the suppose if the power is 3 here and I'm doubling the concentration, so it is going to be 2 raised to 3, means 8 times into double this 2. That means the rate of reaction will be increased by 16 times. So the power only decide that the reaction speed depends on which reactant by how much. Okay, so suppose now I just saw that if I'm changing, or if we are doubling the concentration, or if I'm changing the concentration, then how the rate of reaction changes. Now I said that if you wanted to know the power of any of the reactant, that means if you wanted to know the values of X and Y, then we perform experiment. What we do in experiment? For a time being, suppose we don't know the power. So there is no 2. I just wanted to know the values of X and Y. What we do, the same thing. During the reaction, first I will perform the experiment, I will calculate the rate of reaction, then I will double the from NO and O2. I double the concentration of anyone, either NO or O2. Suppose I double the concentration of NO. On doubling the concentration of NO, I come to know that rate of reaction increases by 4 times. What? This is the rate. Increases by how many times? 4 times. Now the question arises that if I'm doubling the concentration of NO, just think, now if I'm doubling the concentration of NO, that is this 2 NO it becomes. Power is X. What answer is getting outside? From 2 becomes 4. It means what will be the power of this 2? Then ultimately I will say 2 will give you 4 only if the X value will be 2. That means here the power is 2. Suppose I wanted to know the power of O2. I double the concentration of O2, only O2, not NO. So when O2 is doubled, suppose the reaction changes by 8 times. Just for example, let it changes by 8 times. Means if I am doubling O2, let the power is y. How much time the rate of reaction changes? The reaction changes by 8 times. 8 times matlab 2 becomes 8. 2 becomes 8 means what will the value of y? Then ultimately if it is 2, it will become 4. If it is 3, then only it will become 8. So y is equal to what? This is nothing but 3. So this is the way how we calculate or how we determine the powers. We just keeps on changing the concentration of reactant one by one and just see that how much it is affecting the rate of reaction. So on the basis of that, we predict the values of x and y. For a time being, suppose if I am doubling the concentration of O2 by twice, means if I double, rate of reaction only changes by 2 times. If reaction changes only by 2 times, I will say the power is 1 because 2 outside the number, again 2 is inside. When it will come outside, again it is only 2. So power will be 1. Suppose I double the concentration of NO or triple the concentration of NO. The reaction changes by 27 times. If I am tripling the concentration of NO here, suppose I wanted to know the power. If I tripling, this value increases by, the rate of reaction increases by 27 times. Means 3 is getting converted into 27. So what will be the power again? Then simply I will say 3 is getting 27. It is going to be 3 raised to 3. That means the x value is 3. So ultimately we come to know that rate of reaction depends on which reactant, it is decided by the power. Now we are talking about the order of reaction. What is order of reaction? In a simple word, I will say order of reaction also do the same work. Order of reaction also help us to know that on which reactant the rate of reaction depends how much. Means I can say the rate of reaction depends on which reactant by how much is determined by the power as well as by the order of reaction. So simply I can say order of reaction and the powers are nothing but the same. So if the order of reaction is asked, that means you have to think about the powers, that what is a power. So suppose here I wanted to write the rate of the order of reaction. Here the power for A is x and power for B is y. So order of reaction with respect to A. Order of reaction with respect to A means I just wanted to know the power of A. So it is going to be x. So x will decide, or x will tell you that rate of reaction depends on A by how much. Similarly, order of reaction with respect to B, it is going to be y. And overall order of reaction or overall order of reaction, that is n. So overall order means you have to write the overall power. So it is x power for this, and for this the power is y. So it is going to be x plus y. So this is overall order of reaction, that is x plus y. Now similarly we can write the order of reaction for all the reactions whatever we are having on the board. So let's write the order of reaction for this particular reaction. Rate is equal to K into H2O2. So the power is 1. So here order of reaction is also equal to, that is n is equal to 1. And if the order of reaction is 1, then simply I will say that such reactions are known as first order reactions. So it is an example of first order reaction. A first order reaction is a one generally in which the rate of reaction depends only on one reactant and with the power 1. Because if the power becomes 2, it will become second order reaction. So power should be 1. Another example, H2 plus I2 giving 2HI. I wanted to know the order of reaction. So order of reaction with respect to H2, the power of H2 is 1. So it is going to be 1. Order of reaction with respect to I2, the power is 1. So it is 1. Or if I am saying overall order of reaction, so order of reaction, that is n is equal to, it is again 1 plus 1, that is 2. So such reactions are known as second order reaction. Now for second order reaction we have two possibilities. Either there is a 2 reactant with power 1 1 or there is only 1 reactant with the power 2. Both will be considered as second order reaction. For example, in this case we have two components, NO2 and CO. Now in this case I can say order of reaction with respect to NO2 is twice, that is 2. Order of reaction with respect to CO is 0. So if I am writing order of reaction overall, that is value of n, again it is going to be 2, means again it is an example of second order reaction, but in this case there is only 1 reactant and having power as a 2. Now let's talk about this reaction. Here the order of reaction is going to be that is n is equal to 2 plus 1, that is 3, and such reactions are known as third order reaction. So if I'm saying third order reaction, that is the total power is going to be 3. If one reactant is having power as a 3, there is only one reactant, and if it is having a 3 power, then also it will be considered as third order reaction only. Now here the order of reaction is 3 by 2. So a very important point in this case, that is I can say that order of reaction may be fractional. That is a power may be fractional. Now this example, 2 moles of ammonia is giving N2 plus 3H2. I wanted to know the order of this reaction. So rate is equal to K into NH3 raised to 0, that is rate equal to 0. There is only one reactant and that also having a power 0. So such reactions order is 0, and such reactions are called as zero order reaction. Now the zero order reaction is different than the other reactions. Zero order reaction, in case of this, I can say that order is 0. It means the rate of reaction does not depend upon the concentration of any reactant. See what happened in all the reactions. In other reactions, I can say, suppose in the beginning, in case of other reactions, if I am drawing a graph of rate versus time, what happened in all the reactions? The rate of reaction in the beginning, rate is directly proportional to the concentration of reactant. So in the beginning, reactant is very large, and hence the rate of reaction is very high. But with the time, what happened? The reactant goes on decreasing, it goes on consumed. So rate of reaction also goes on decreasing. Matlab in the case of first order, second order, third order reaction, what happened? With the time, the amount of the rate of reaction goes on decreasing as the concentration of reactant decreases. But when I'm talking about the zero order reaction, what happens in zero order reaction? Rate does not depends on concentration. So with time, if I'm plotting the rate, what will happen? With the time, the reactant will goes on decreasing. But since the reaction speed does not depends upon the concentration of reactant, hence initially with whatever the speed the reaction will start, with all the time the rate of reaction is going to be same. It will not change. Means it is going to be parallel to time plot, or this x-axis I can say. So rate of reaction remains constant in case of zero order reaction. In other reactions, I can say, like in case of first order, second order, or third order reaction, in those cases I can say that for time required for the completion of first 10% is very less compared to the last 10%. Means we know that with the time the rate of reaction goes on decreasing. So if the question is like whether more time will be needed for completing first 10% reaction or last 10%, so simply the last 10%, because at the end of the reaction the speed is going to be very slow. But in case of zero order reaction, the time required for completion of first 10% as well as last 10% is going to be same. Or I can say for in between 10% also the rate of reaction is going to be same. So zero order reaction, a very important one, I can say reaction in which the rate of reaction does not depends upon the concentration of reactant and remains constant throughout the course of reaction. It remains constant, does not changes with the time. So this is about the order of reaction. So if there is a question on the order of reaction, then simply have to think about the powers. And since, as I said, order of reaction, it is equal to x plus y, that is sum of these two powers. X and y is determined by performing experiment. So if you wanted to know the value of this order of reaction, then also you have to perform experiment. Means order of reaction is again experimentally determined quantity.